Alright, so today's going to be short and relatively to the point. So you've got 3 different sections in the notes, and there's a bunch of properties up here that you need to know for your logs and stuff. So basically, we know that anything to the 0 power gives you 1, right? So if you have a 1 inside your log, that means it has to be 0. If you've got the same base and the same number here, then it's going to be 1, because like anything to the first power is going to give you itself. If you have this base number and this base number are the same, so you've got like something to the log of the same number, then it's going to be whatever this number is. And then if you have the same numbers here, then your R is going to drop out, or your exponent will drop out. So that's all those are saying, and you'll see that when we do those here. If you are multiplying inside your log, you can separate it by adding. If you're dividing inside your log, you can separate it by subtracting. And if you have an exponent inside your log, you can pull it to the front. That's basically it. Is that okay? The last section is talking about change of base, which is something that you had to use before you got fancy calculators. You have fancy calculators, so it's kind of obsolete for you now. You don't really need it, but it's a way to figure out like a different base of your log, because it used to be that logs or calculators would only do log base 10, and so you would have to change it to find like log base 2 of 16 or whatever. You'd have to use this formula to get you there. So I'm just going to show you all that, but you probably won't ever use it. Is that okay? All right, so for the first one, this looks like which one of these? Option 1, 2, 3, or 4? Option 3, right? So since these numbers are the same, what's going to drop out and be our answer? Pi. Is that okay? All right, looking at number 2, does this one look like option 1, 2, 3, or 4? Option 4, so your exponent drops out to be your answer, so negative square root 2. Is that okay? All right, looking at number 3, we've got natural log of e to the kt. So natural log of e kind of cancels each other out like this one. So remember, natural log is log base e. So it's essentially like this, of e to the kt. So that's why we use this rule here. The exponent there was 1, so your exponent drops out here. So it's kind of like this one, I guess, when we write it that way. Anywho, your answer is just kt there. So anytime you have natural log of e to the something, to some exponent, it's just your exponent. And then for the last one there, what do y'all think that one's going to be? 1. Is that okay? Questions on any of those? All right, cool. So the next section, we are going to rewrite these using like the adding and subtracting to separate our multiplication and division. So, yeah, we're going to start over here. So we've got x times the square root of all this stuff. So we can go ahead and separate the x times the square root stuff, right? Yeah. So we're going to have log base a of x plus. And then, can we rewrite a square root as an exponent? You can. What is the exponent in there? 1/2? Yeah, is that, do we not know? Okay, so maybe jot this down. If you have the square root of x, it's the same thing as x to the 1/2. That's something that we should have learned a while ago, and maybe it just got lost. I know they changed the standards of when you cover that, so it may have just got skipped in between y'all's like math 2 and math 3 at some point. But anywho, so we're going to take all of this stuff here and put it to the 1/2. So we'll say plus log base a of x squared plus 1 to the 1/2. Is that all right? Questions on that? Yes, no, maybe? We're all right? Okay, so then from there, we're going to move the exponent to the front, and that's basically all we can do to simplify that. So we'll have log base a of x plus 1/2 log base a of x squared plus 1. Questions? Alright, so that's it. Looking at number 6, since it's dividing, we can separate those by subtraction. So we'll have natural log of x squared minus natural log of x minus 1 cubed. Is that okay? your denominator is always going to go second, so like minus your denominator. I know that's confusing sometimes, or it has been confusing in the past for some people. What's one more thing that we could do from there? Pull your exponents to the front. So we'll have 2 natural log of x minus 3 natural log of x minus 1. Questions? Alright, so moving right along to number 7. We have a lot more going on here, but it won't be bad. We're going to go ahead and do the division part first. So we'll do the numerator minus the denominator. So, and I'm going to go ahead and rewrite that square root as the exponent of what? 1/2. So 1/2 minus log base a of x cubed times x plus 1 to the 4th. Are we okay with that step? Okay, so then from there, what can we do with the first part? We're exponent to the front. And then over here, since we're multiplying, can we separate that further? Yeah. And then what's the last thing that we could do? Pull the rest of your exponents to the front. Oh, I didn't do that. I said that and then didn't do it. And it might be a good idea to do parentheses around this part, just so we know that all of that was on the denominator. And so I'm going to throw that in. Yeah. Is that okay? So you could have them up here too. Questions on anything? Very cool. So for number 8, if a square root is x to the 1/2, what do you think a cube root would be? X to the 1/3? Yeah. So we could say that this is just log of x to the 1/3. And then how could you rewrite that? 1/3 log of x. Is that all right? Any questions? Okay, cool. So now we're going to take them, that was like expanding. And now we're going to condense them. So we're going to make them smaller. So if they are adding, what are we going to do? We'll multiply. What should we do with this 4 in front? Move it to the exponent. So this is really just going to be log base a of 7 times 3 to the 4th. Is that okay? Makes sense? I hope. So we've moved the 4 to the exponent of the 3, and then because these two logs were adding, you can multiply in here. So then 3 to the 4th times 7 gives you 567. So we would just leave it at that. And I'm definitely not expecting you to know that. So, yeah. Is that okay? All right, cool. So looking at number 10. We can go ahead and do what with this 2/3 exponent? Or 2/3 out front. Move it to your exponent. So you're going to have natural log of 8 to the 2/3. And then on the other natural log, we have 5 squared minus 1. Can we figure out what that is? 24. So we'll go ahead and simplify that. Is that okay? So could we do 8 to the 2/3? 8 to the 2/3. Can we do that? So I'm assuming that we probably don't know what 2/3 means. You don't need a calculator for this, so put them down. So when we had a cube root up here, the exponent was 1/3. So this is going to be like 8, the cube root of 8 squared. So I think it's easier to go ahead and take the cube root, because the cube root of 8 is what? 2. And then square that when you get 4, right? Is that okay? So that's just going to be natural log of 4. So you didn't need a calculator for that. That's natural log of 4. Yeah, but you can do it without the calculator. So since they're subtracting, what can we do to put this into 1 log? Divide. So natural log of 4 over 24. And what does that reduce to? 1/6. So it's a natural log of 1/6. How could you rewrite that with an exponent? Six to the negative 1. So this is natural log of 6 to the negative 1. So what's one more thing that we could do from there? Move the negative to the front, so this whole thing would be like natural, or negative natural log of 6. Is that all right? Questions?
Because you keep saying natural log, but the L is in front of it. That messes it all up.
Regular log? This is a regular log with a base of e. It's a regular log with a base of e. It's just a different...
What's the A then?
It's just a placeholder. It's just a variable in that case. But e is like that 2.7 whatever number that we talked about yesterday.
Oh, yeah.
Alright, any other questions right now? Alright, so let's try another one. So, what could we do with these that are all being added? Multiply. So, I'm going to do log of a 9x times x squared plus 1. And then we have minus log base a of 5. So since they're subtracting, what can we do to condense it just a little bit more? Divide. So we'll have log base a of you could distribute on your numerator if you wanted to. It's not really going to change anything, so we can just leave it there if that's okay with y'all. Questions at all? Is that okay? Alright, so look at number 12. What are we going to do since they're subtracting here? Divides. This is just natural log of x minus 1 over 6. Questions? So the bottom section is just showing you how to use that change of base formula. So again, you don't have to do this because your calculator will do this log anyway. But back in the day, before you had smart calculators, you had to use your change of base formula. So basically, you just do 2 logs divided by each other. So it's the log of the top of the big number. So we'll do log of 89 over the base goes in the bottom. So like a basement. I don't know if that helps you think of it that way. So log of 5. And when you type that in your calculator, you get like 2.79. So if you use your calculators where you don't have to change base, you can just type this straight in, you still get the same answer. So like I said earlier, you really don't need to know this formula. Right? Okay, so how would we set up your change of base formula for the next one? Log of what? Square root of 5 over 22. Yeah, is that alright? And so again, when you type that in your calculator, you get 2.32 this time. And you get the same thing when you type this in as well. And we said we know how to do those in our calculator, correct? Okay, great. Questions?